think we'll dive into it. At this point, it's 10:30 now, so we'll get started. Please use the chat. The actions, the toolbar should be at the bottom of the screen where you can open up the chat window as part of that. And yeah, love, while we're getting started and doing the initial introductions, if you could type in why you think compressing or optimizing your compressed air is so important and why do we care about that, that would be great. Getting in today we are looking at opportunities for compressed air systems. This is, we're going to be doing kind of an expert Q&A format to this. So I'm Jay Mullen from Goldfin on behalf of Save On Energy, and I'll be facilitating today with, we have guest presenters, Dino De Filippis from Airenergy and Stephen Dixon from TDS Dixon as our subject matter experts for today. Looking forward to that. So welcome, Dino and Stephen.
Thank you. Morning.
And what we're going to do for today is we're going to start with a quick case study interview with one of our energy managers who's kind of going through this whole process of optimizing their compressed air system. Then Stephen's going to go through kind of a virtual walkthrough of what to look at if you're starting to look at optimizing your compressed air system. And then we're going to get right into the expert Q&A and hopefully have a fair bit of time for that. Thank you to everyone who submitted questions in advance. If you have any questions that come up during the interview, during the virtual walkthrough, or anything else, please add them to the chat. We will be using that as we go through and hopefully take up those questions as we go. So before we dive in, let's see some people's energies. Why do we care so much about optimizing compressed air? Because it takes energy to compress air. Yeah, it takes a lot of energy to compress air. So that's a great reason for it. Dominic says is the biggest loss in their plant. Manufacturing a lot of facilities, compressed air is one of the biggest energy users and one of the biggest sources of energy waste within facilities. Augie mentioned that it's very inefficient. If anyone had a chance to watch the video on why we care to optimize compressed air, you may have noticed that compressed air is only about 10% efficient typically when you go from energy going into the compressors to work being done. So there's a lot of potential to reduce waste, to reduce energy costs that come out of it, and that's why this is so important.
Jay, I like to on that note, I like to think about compressed air as being worth $1 per kilowatt hour in the form of energy. So if you're paying 10 cents at the source, you're basically air in the form of pneumatic energy is worth about $1 per kilowatt hour. So.
Yeah, and I think if your bills were $1 per kilowatt hour, you'd be paying real attention to where you're wasting those kilowatt hours. So starting up with the interview, I would like to introduce Dominic Vita. So he is the energy reduction leader at Prestran Industries in automotive manufacturing. Relatively new to the company. I believe he started it just this past spring, Dominic, but has really dove in terms of finding energy saving opportunities with a big focus on compressed air. So welcome, Dominic. Thank you for joining us today.
Thank you.
And I mentioned, you did just start this past spring, and as part of, an energy manager within the energy manager program, you have some short-term targets and energy savings to hit. So I'm curious as to, a lot of the opportunities you're looking at came from the compressed air system, but what were some of those initial hints that got you looking at compressed air or focused on compressed air as a way to generate energy savings?
Well, the first chance I got when I started early in March this year was to come in on a weekend. And of course, on the weekend gives you some special opportunities to find energy opportunities. There's not X number of robots working and moving, and fork trucks driving. So you can walk around freely and make note. And one of my visits was in the compressor room, and we had some quite big 3-cell airs, all 350 and 300 horsepower. So there was over 1,000 horsepower there. And of course, as an energy engineer, that triggers a few things. And then the flow meter. There was, you shoot a cannon through the plant, and we were using 640 CFM. So that was the first clue.
And that's when nothing, like on the weekend when there was no one in there, no production going on.
Nobody, just myself and the facility manager.
Okay, actually, I did forget to mention before we get in here, Helen's going to be sharing a worksheet that we prepared that we've gone out by email beforehand. If you want to use that to write down any ideas for opportunities, you can go that. And if we have any questions as we go through this, please feel free to add them into the chat. So just the size of the compressors, the amount of energy that they're using, and seeing how much air you're using when you aren't really in production mode at all. That was sort of a good hint that might be a good place to look. When I got to finding specific opportunities to reduce that energy, what were some of those that you found, and how did you kind of like prioritize, where to look or which opportunities to focus on?
Well, to get familiar with the programs, Magna is great. We have some engineering team meetings with good training, and one of them was compressor, like somewhat like this course, and we talked about the Fluke II900 and leak detection. Early in the year, an intern mentioned this $22,000 device, and I go, however could we afford that? And very quickly, within a couple of meetings in a few weeks, we learned that the II900 leak detection was the tool to have for leak detection, and that was the focus. Am I trying to convince a company with very little funding that we have to spend $22,000? And so I had to demonstrate that, and so that was one. The other one learning was the zero loss valves from the training we had, and also follow compressed air best practices online in their seminars.
Great, and you mentioned that one of the challenges was getting funding to implement these opportunities or these projects to save energy on there, and you managed to, like you mentioned, like there isn't really budget available, but you still managed to move forward with these, like you said, purchasing the leak detector to get that leak management program in place, getting those zero loss drains in there. I believe you're looking at engineered nozzles as well. So what did you do to kind of overcome that challenge around budget?
I think what happens if anything that looked like a DC drive optimization reduction was going to be a 5-year payback, and those programs were hard to execute. And my mandate was from March to December 31st, so that kind of pushed you to a certain type of programs you could execute quickly. So I started on the hunt for those. Then the funding aspect of it was, what can I do that's compelling? If it's a 5-year payback, it's not compelling. If it's a 3-year payback, they start to listen to the program. But if it's a 1-year payback, controllers understand it. So after it's a 1-year payback, such as the lighting or engineered losses and the zero loss valve, all those are sub 1 year to 1 year paybacks. And then the controller says, well, if you can prove that we can save this year, I'll pull it out of my GL budget for paying the electrical bill. And so that's what they did. So they trust me with my calculation to show, yes, you will save this from your energy bill. So it's a tall order that we have to execute properly on those programs. So I have to tread carefully.
Right. I think that's a really good point you make, Dominic, is that you've got to quantify the opportunity. And I've always said that for any kind of opportunity, but I mean, an idea to save some energy or avoid some consumption is good. But if you can put dimensions on that idea then has legs and can go places. So I think that's a really universal thing. And the more you can quantify that opportunity, the more traction you're going to get. So then you've demonstrated that nicely.
Thank you.
Yeah. And from those, is there, from any of those projects, are you starting to see kind of the fruits of the labor, or any results that you're excited about, or that you're excited to kind of see the results of?
Yes, I mean, the one I'm really excited about was, well, it showed immediate impact when we dropped the pressure in the plant. We didn't have to run at 115 PSI. We could keep dropping that and we tried 5 PSI for now and a little bit more, and we could see 30 kilowatts right on the power meter impact overall, and you could see that immediately. And then the leak reduction programs, we saw the best months ever in kilowatt reduction in the plant on the weekends. I started a trend. Unfortunately, the trend reversed recently with more leaks happening in the plant. So now we're going to be a hunt for for other issues. But the one that I'm excited most about is that one area we're blowing slag off wells. If slag gets in one nut, the customer cannot screw the nut in assembly. So we have 8 quarter-inch full flow airflow nozzles at 94 psi blowing for 60% duty cycle to keep weld slag out of the nuts. And I've using X-Air nozzles have more flow for 1/5 of the airflow on those 8. And I'm just working through the quality concerns of making the change in an automotive system. It's very difficult. I have to do a temporary change notice, do a study, look at the quality, every part coming out of that for a period of time, just to make one change, and it's almost a like for like.
Mm-hmm. And that's moving to engineered nozzles that, you know, you get more like effective air coming out of there for less compressed air use on it.
Yeah,
and that's the quality is such a big issue that you have to deal with there. Right?
Yeah, the one quality problem at the OEM would just blow the savings out of the water, you know.
Mm-hmm. So it's important to be
a
really
recall on
careful.
parts. It could be $100,000 problem, right? And you're saving 20,000, right? So that's the you have to be very careful in automotive changes within the build systems.
In terms of you know, the next steps or the projects that you're still working on or opportunities you've identified but haven't fully kind of sorted out the issues, are there any kind of key ones that you're looking at in terms of next steps?
I thought it was a slam dunk with compressor optimization and adding a Sigma Air Manager on our compressors. And when I started asking questions of how they wanted to do it, I couldn't get the answers that I wanted. I was very interested in getting a kilowatt per 100 CFM, you know, history on our Solairs. And because they're a Kaiser product, they work well with integrating with their products. But with Solairs, they were just more interested in here. Give us our $35,000 to $40,000. We'll put it on and we'll manage everything for you. Don't worry about it. Don't worry about kilowatts per 100 CFM. It doesn't matter. We'll make it work. And so I tried to ask for a study to quantify that and get a stamp, confirmed savings. We needed to do an air demand analysis for $3,000, and we just couldn't see in our heads, you know, for our setup with 3 large compressors, how we could save, you know, $40,000. You know, even with a 7% gap reduction, you know, from one compressor to another, could we see that saving? So I got stuck on that. You know, I thought it was a good program, but I just don't have the expertise to get through that.
Because right now you run 2 of the 3 compressors at a time. One of them has a VFD, and you're using like cascading pressure bands to kind of control when they come on. Is that correct?
It's about 7 psi.
Yeah.
The variable has 3 different set points. It has a kick on to run to about 105 psi. Then it'll try to optimize and keep at 100, and then after it drops that for a while, then it starts after 10 minutes drops down to a lower trigger set point.
Okay. And Dino and Stephen, is this, you know, an issue that you've seen at other facilities, or kind of a common thing that comes up when people start looking at, you know, the nuts and bolts of that compressor optimization and what it looks like in real applications?
Stephen, you want to start?
I was going to suggest, Dino, you've done quite a few of these sort of generic ones. I think the thing that Dino really emphasizes is that you kind of have to look at what you're actually doing to the system in a fairly generic way, and then understand whether that, whatever controller you're going to use can achieve that and what you have to do. So, Dino, I'm going to flip that over to you. I know you love this one.
Well, no, I'm familiar with the compressors and the ADA from and the Sigma from Kaiser, but there are controllers out there that are equipment neutral that will communicate with the Solairs and provide you with all the information you need on efficiencies and key performance indicators such as kilowatt hours. You could also tie in other ancillary equipment such as flow meters and dew points, depending on how, if you've got what type of dryers you have. So there are systems out there, Dominic, that will work quite well with your Solairs.
Mhm. And in terms of the savings on there, is in this kind of setup, is the main thing, coming from being able to reduce that pressure of the initial one because it's not the cascading bands, or with their setup, like they have three fairly similar sized compressors, and in terms of would there be much savings from optimizing the sequence or order that those come on?
It would be, I'll be honest with you, the savings, if he's using a variable to trim on a fixed speed compressor, I would have to look at what power charts, Dominic, you have so far. But if you're running the fixed speed at full load and the VFD is only trimming, controlling that would only allow you to optimize switching compressors 1 and 2, the 2 fixed speed with the VFD still, and allow you to possibly use the VFD only on the weekend. But the compressor gap between ranges, it'd still be a tight 5 to 7 PSI. So
Yep.
calculating the energy reduction with a controller, I would say that there's probably not a lot of savings.
Yeah, and that was my conclusion as well, Dino. But we did, in optimizing, switch to the variable speed on the weekend, so that's working quite well.
Yeah. So I'd be more than happy to talk to you in more detail after. But if you have any power graphs on the 2 compressors during the week and on the weekend, I could take a look and give you my 2 cents.
Yeah, we're instrumented very well. I'm very happy with our system.
And I think that really speaks, and Dominic, I think you did a good job of this. Was some of your early steps is getting and looking at that flow data and getting an understanding of how the system behaves in different modes. Like how is it currently behaving during production hours? How does it currently behave on the weekends? And what compressors are coming on when, and does that make sense? And I think that really speaks to part of that process of looking into where these opportunities are, of getting the solid understanding of what your demand profile looks like and how that relates to your system.
Yeah, I guess I'm glad my decision is, if it was my $40,000, would I quickly spend it just to say I did a compressor optimization program, just like the other plants did? It's a standard tool. Just do it. It works. But maybe in this case, it didn't work.
Or, you can get similar benefits from, like I know you mentioned that you started manually switching the sequence order between, during the week to weekends to kind of get the VFD running on the weekends. So is it, the savings between that and having the compressor that will do that automatically and take the manual aspect out of it, but it may not be much incremental savings.
Absolutely.
Just a quick comment on that, Dominic, where there aren't 2 Magna plants that are identical, regardless of their stamping. And the amount of plants I've been in, no 2 plants are a cut and paste where you can take a controller optimization that worked in one and believe it's going to work in the other one. Everyone needs to be analyzed individually to see what works. In this particular case, you've got 3 large horsepower. They're virtually all identical in horsepower. Where's the energy savings other than on a fixed speed, eliminating the load, unload? That's why it's critical to look at how they're presently being operated and what you're doing on the weekend. Essentially,
that's where, that's a good point. There are points where if you use the variable and to run first and able to then say, okay, now I've crossed the 1,000 line. I know my 300 horsepower fixed one will run great at full load. Let's go switch the job to him now. We don't have that optimization where we start out in the day, we know we're going to be running at 800 and we keep the variable as a secondary. And so we build up to that. And as soon as it crosses the 1,000, then the variable kicks in to get us to the 1,200. But so we were always starting first with the fixed and not the variable as the primary.
Okay.
Because I think in optimization now, the light bulb has lit. You mentioned that having an optimizer that says, okay, let the variable do the job first. When it's full, we got a full load for a load unload compressor. Here, you take over now, and I'll sand back. So that's where the optimizer would work.
Yeah, I agree. Yep.
And the other thing to keep in mind is that variable, once it hits full load, it's probably going to use marginally more energy than the fixed speed will be because of the drive in there. So that's what the other reason you want. I mean, it's only a couple of percent, but still, it's not going to be as efficient at full load because there's the drive electronics in there too. So that's the other piece that enters into it. So
Yeah.
What's interesting? Yeah, go ahead. Sorry.
I see that how we could optimize this, that we don't have that right now.
Mm-hmm.
Switching primary and secondary based on a full capacity.
Mm-hmm. All right. Well, thank you very much, Dominic, for this insight. I think I really I appreciate you taking the time today, and I think it's a very useful lesson and kind of illustrating that process of, coming in, starting to look at it, understanding the system and where those opportunities are, and kind of building on those through the optimization process. I think it's a really great illustration of that, and you're starting to see some of those results. So thank you very much. If anyone has any questions for Dominic, you can put them into the chat, or any questions about anything that was brought up, get them in there. We'll address them as we go on. Right now, we want to move into, seeing that real life example of what Dominic has gone through. What do we consider kind of an approach to looking at compressed air efficiency and improving that, and a kind of general approach that you can look at in your facilities?
So I'm going to jump in here, Jay, and sort of talk a few minutes about this and sort of lead Dino through the walkthrough. But I just want to highlight one of the questions that's just come up in the group there from Shannon, and she asked about, she's got the same situation. So Dino, I'm going to put that question out there. What's the simplest way to ensure that you can start with the VF, the variable speed compressor, and then switch over to the fixed speed for the base, and then move to the variable as the load follower? So that, or the trim compressor. So I think a lot of people might have that same question. And do we need a very expensive controller to do that, or is there an easier way to do it? I don't expect you to answer me right now, Dino, or if you want to, that's fine. But let's throw that one into the mix of questions, because I think that would be useful to other people as well.
Okay, no, definitely. There are optimizers that will take a look at the VFD and switch to fixed speed if it hits a certain capacity or KW, to be honest with you.
Yeah, it's interesting. Years ago, we did that with, we had some smart techs in a plant, and they actually used just a PLC controller to do that. They had some air monitoring and pressure and so on, but so they were able to do it with a sort of a generic PLC system and a smart programmer. But maybe it is something you want to use an optimizer for. So, well, actually, it's interesting when you look at a compressed air system. Everybody probably has some favorite areas that they jump to. But ultimately, at the end of the day, because of the fact that we talked about earlier, that the overall system efficiency going from what I call wire, electricity in, to work, pneumatic energy out, is about 10% or less, give or take a little bit. Because of the fact everything you pull out requires the system to work, really the logical place to start is where the end use is. And it's the same thing for many opportunities in energy. We have to start with what is the requirement. What is the requirement in terms of the flow, the pressure, the quality, and so on of the air coming out of the system, and then working our way back up to the system. Obviously, I'm not going to read all the notes on the slide, but there are opportunities all the way through the system. Leaks are always a big one people go after. But what we've just talked about in terms of the sequencing of the compressors in a multi-compressor system, or the ability of the compressor to follow the load, we can fix all the leaks we want. But if we haven't got a system that's capable of following the load downwards as it decreases because of decreased leaks or decreased inappropriate usage, we're not going to see anywhere near the same level of benefit. So we have to take a holistic, a systems level approach, meaning looking at it from one end to the other. So in the next slide, Jay, we've kind of got that methodology laid out, is that we want to assess the system basically from one end to the other. So, and Dino, you typically start in the compressor room and walk out, through the compressor room out to the plant, right? And we're going to kind of go through that. But then the action really has to start at the point of end use, working our way back up to the supply side of it to make sure the system can respond to everything we do or require of it at the point of end use. So it's kind of a logical approach. So it's the same thing I would do in any energy audit. I would start out at the bills, all the energy inputs to the building, and I would disaggregate them, walk out through the building to the end use, and then I would start looking for the opportunities at the end use and work my way back up through the system. And dealing with how to best meet that real demand and how to eliminate that artificial demand or inappropriate use or leakage. And just to define those things, leakage, I think, is pretty simple. Most people know what leakage is, and air that leaks out through either just, well, it could be the no or loss valves, right? So when you're on your drain valves, we can have leakage there, or it could be just through leaks in pipe. Artificial demand is where your pressure is unnecessarily high, and then even leaks and inappropriate uses are higher at that higher pressure. So artificial demand caused by artificially high pressure or inappropriately high pressure, and then inappropriate uses, like we all know the classic one, which is sweeping the floor with the compressed air. Now, what's interesting about that one too is that sometimes that can have an impact in other parts of the plant or the operation as well, because it may be that somebody opens that valve to clean the floor in the machine shop, but that creates a pressure transient in the system, which causes problems elsewhere. In order to overcome that, we jack the pressure up even higher in the system, whereas maybe we could, deal with the inappropriate use, or if the use is appropriate but still transient, deal with that with appropriate storage capacity, which moves us back into the other parts of the system. So really, it's a very logical approach, but I think Dino will tell us that the first thing we have to do is understand that system. I think Dominic said that too. We've got to understand that system from one end to the other. Some of that we'll be able to do ourselves, and some of it, and I would suggest that there's a place for sort of the knowledgeable professional here, not necessarily the vendor of equipment, right? Because what we want to do is have somebody that's going to look at, from our point of view as a user, and make sure that we're using the least amount of energy to achieve the greatest result. Actually, on that note, although we talked about engineered nozzles earlier, I'll even mention the fact that engineered nozzle, I know, Dominic, you were very concerned about what's happening at that when you clear that weld flash. But my experience, and maybe somebody's got a packaging line out there using an engineered nozzle on a packaging line where we're using the air to move a product or close a lid or something, you can actually achieve a greater result, more reliable result sometimes with that engineered nozzle than and use it for less air. So you can enhance the result and reduce the energy. And to me, that's always got to be the goal. I mean, Dominic, you said it, we don't ever want to compromise the quality, because that can be a very costly thing for a small amount of energy cost avoidance. So, Dino, when you're looking at a system, what we're going to do here is going to kind of take, use Dino's eyes to walk through. How many plants have you walked through, Dino? Probably 100, 200. Am I probably on the low side?
Probably on the low side.
Yeah.
Been doing it for a few years.
Yeah, so let's just take a walk through, and these slides are going to be provided afterwards with a little bit of enhanced sort of verbiage attached to them. But right now, we simply want to highlight the things that need to be looked at and maybe what that can identify as opportunities. So you're starting out in the compressor room, and I think, Dominic, this is where you started too. You walked in the compressor room, and well, two things you saw. One is all the compressors, the size, and the other one was the flow, right? When nothing was being done in the plant. So Dino, are there some highlights here that you can identify?
So when I do audits, obviously I start in the compressor room first. What type of compressors, single units, multiple units, how they're connected, whether or not they're communicating with each other. Is there a redundancy built into the system, as some customers have them, some don't, and how everything is laid out, wet, dryer, filtration, receivers, dry receivers, flow controllers, so on and so forth. So I spend quite a bit of time in the compressor room analyzing the equipment and how they're working together.
And that actually really leads us into the next slide there, Jay, which is sort of the controls, right? And how the compressors are actually being controlled against the load. I remember walking into one compressor room, and this was in an automotive parts manufacturing facility too, and they had 3 compressors running. It turned out at the end of the day, one of them was basically overcoming leaks, and one of them was just because of the control settings, was simply on, never cycling off because of a transient event. After a little bit of work in that plant, they ended up with 1 compressor running basically all the time. So, Dino, anything to highlight here? Any of your favorites?
Usually when they have multiple compressors, the service company, the incumbent service company, will set them up in a pressure cascade, but depending whether or not there's the modulation mode or load unload mode, that's critical. I look at how they're set up. And I also look at the history of alarms. The history of alarms gives me a good idea what the compressors have been doing, how they've been operating, what issues have been going on with power or temperature or maintenance, so on and so forth. So all that goes in an audit study.
Yeah, I mean, the next one is kind of, it's not about compressed air, it's all about the room that contains the compressor system, but what's happening there. And there's some very simple things we can do to ensure the compressors are operating in a healthy environment from a, an HVAC point of view, and also maybe utilizing some of that heat that's given off, that 90% of the energy we're purchasing, that maybe we can use elsewhere.
Yeah.
Any highlights on that one, Dino? Have you any, what's worst case there? Filters that are filthy, dirty inlet filters, things like that?
Or, well, an example in this particular photograph is that they got a heat recovery into the building for the winter time into the compressor, but they have no fresh air supply into the room, so that the room is always under negative pressures. The temperature on the compressors rise. And they don't close the louvers during the summertime. So the compressors have always been shut down on high temp. And as soon as we opened up one of the man doors, the temperature, actually you could see the temperature on the compressor start to drop. So there was duct work issues here at this particular customer.
As big and as tough of machines as they are, they still like to be treated properly.
Yeah.
The next slide, really, we've talked a lot about this in the interview with Dominic, is compressor sequencing and how best to do that. So, is there anything you want to add on this one, Dino? And I'm sure we're going to come back to this one in the question and answer later too, right?
Yeah. And the only thing I would say is it a smart control? In other words, does it have the algorithms built in to pick and choose compressors during normal operation from a Monday to a Sunday? Any controller can start stop, but does it have the brains to do more than that?
It's interesting. I'm going to go back to something Alan Sutton said in the chat a little while ago. They've gotten through an 8-week project, I think, Alan, and you ended up shutting off your whole compressor plant, which is a massive plant, for 35 hours a week, and that's at your Toyota assembly plant in Cambridge there. That's huge. Now, can Dominic do that? Can any of you do that? That depends. I mean, that 8 weeks probably was determining what you had to do to avoid problems when you shut it down and restarted it. But that's a huge opportunity, right? Not technological. It's going to take some effort, and you're going to have a payback against that. But yeah, that's something you got to look at too. That's the ultimate in sequencing, is just not running them. Thanks for that, Alan. All right, Jay, let's go to here's another one. I mean, Dino has so many stories on dryers, and like, for example, over drying air, right? Where you're using a desiccant dryer and you're really not aware of what the settings are and the amount of purge that's required on a desiccant dryer. Big opportunities here, correct, Dino?
That's correct. And the first thing when I see any type of drying system in a plant, I'll always ask the customer, what are the requirements for compressed air quality at the point of use? Whether you're stamping, pharmaceutical, or food, there must be some sort of an SOP or a compressed air quality document that we need to look at. And most of the times they're over-designed or under-designed, or if they're just a heatless type desiccant dryer with no purge economizer or dew point energy mode, we're blowing 15% of that compressed air out the exhaust muffler. So it's good to look at what the requirements are at the point of use on the demand side to properly know what sort of drying you need.
Excellent. So moving out into the system, or in general, preventive maintenance, I think, it goes without saying. I always like to say maintenance equals efficiency equals reliability. So for me, preventive maintenance equals, avoiding energy consumption you don't have to have. Dino, there's a bad story on that one, eh? What's that? Is that insulation? No, that's actually a filter, isn't it?
Those are filter cartridges inside a pre-filter. So there's lots of stories that go with maintenance. You could be running around in circles trying to reduce energy, but if your compressors aren't up to peak operating condition, and you will have to work with your maintenance manager, your maintenance department, to ensure that the PMs are being done on the inline filters, that there's no pressure drop, your compressors, your inlet filter separators, oil, all that's being properly maintained.
Moving out into the system a little further, the storage. How much storage you need in your system, right? How much storage do you have? Would you put storage at the compressor plant, or would you put it out in the system? As I said before, that event that took place out in the plant may be mitigated by simply a tank in the right location within in the plant itself. What's the story behind this picture, Dino?
Well, that's a food plant where they had point of use satellite air receivers installed at many locations. But the reason they did this was that the distribution header was too small. So they design a header, they design a pipe diameter to the process, continue adding other pieces of equipment to find out that the original pipe size was too small. So they're choking the air to the process, and they installed point of use tanks. So people have asked me, what size tank do I need? The bigger, the better. And if you could properly size a distribution system, you could really eliminate the point of satellite tanks. And if you can't change the piping system, then you use satellite tanks.
So there is a solution. It's maybe not the straightforward one, but lots of different options for you. All right, moving on from there, pressure regulation, which is not which is not disconnected from storage as well in the system. We've got it looks like a pressure regulator here. What's the purpose of the pressure regulator for, Dino?
That's a pressure regulator, or what they also call an intermediate flow controller, is to create a true supply and demand. And when we look at a compressed air system, we know the supply is the compressors, the demand is the obviously the point of use applications and usage, but that pressure flow controller actually provides additional storage on the dry tanks at a higher pressure, and we regulate only what we need in the plant, the minimum amount of air pressure we need at the plant. Sending 110 psi to the plant when the plant can operate at 100 or 95, that's an energy waste. Obviously, Steve, you touched on the artificial demand and leakage, but that regulator will actually control the minimum amount of air that we need. And as you choke down on that pressure regulator, and Dominic has seen this happen, you actually reduce the amount of load you put on the compressors.
So let's keep going here. We've got a few minutes to go. Piping issues. This is a great one. I'll let you tell the story. One of my favorite ones is seeing two compressors. You can see my hands here that had discharged together into a T basically, and they had the outgoing line, and that collision point there between the air is a major pressure drop. Well, this is a major pressure drop too, Dino.
That's correct. So that original picture where you saw the compressor room with the three compressors, this was actually the wet receiver that was installed. For whatever reason, no one was able to explain it to me why we had a 6-inch header into a 2-inch air receiver connection. That was the choke point. They were having issues with pressure downstream. They felt that they had to run all the compressors, and as I followed the receivers, obviously that's the first thing that the light bulb kind of goes off, and the recommendation was get rid of it and put a properly sized air receiver with proper size connections. The other thing, so that's go ahead.
How many psi do you think that would rob in that system?
Well, they're trying to run 3 compressors. They actually only needed 2, and they were 125 horses. If that had been, I would say that if memory serves me correct on that one, they were running the plant at about 110, 111, and they were probably getting about 97, 98 out to the process. So even if they tried to reduce the pressure from an energy point of view, that would still be the choke off point. So when we're looking at, and I just a quick note, when we're looking at reducing energy and pressure, like Dominic did a great job at Prestran, it's all the other piping and distribution and filtration that needs to be looked at to make sure that we're not spinning our wheels.
So at the end of the pipe, then we're going to have some use and some filters. So what about those filters, Dino? Is there an appropriate type of filter? Are there choices we have at the point of end use or in the system?
Every company is different. So if you're a food company or pharmaceutical, they'll want point of use filters to ensure that there's no particulate. Normally, I find in the automotive industry, they don't worry about point of use filters. The air there just has to be general purpose air quality. The reason I put this out is that very seldom does the maintenance team ever know that there are filters sitting in the ceiling, and they're not on a PM program. And when they start running into the problems with pressure and the machines aren't cycling properly, the first thing they do is they go increase the pressure on the compressors. Yes, it solved it, but here's the issue. There's the problem. Need to make sure that any point of use filters, including FRLs that are actually on the equipment themselves, that they're on a regular PM, that they're being replaced. Too often, compressors are adjusted in pressure to compensate for something else happening on the demand side that should not be occurring.
And I can see where those filters might get less attention than they need to, given their location as well.
Now,
Next slide.
These are sitting over a palletizing area. You can't get up there with a scissor lift or a ladder. And I just said, this is crazy. So my recommendation was, you didn't need it. You had proper filtration. You had copper pipes soldered. Take the elements out of there and leave them empty. You don't need it.
So moving to the end use now. And you talked about pressure settings. You talked about PM on the FRL units. Anything else you want to highlight on this one as we sort of draw to a close?
This is just additional reduction in pressure. And the reason I took this shot is because there's a yellow tag up there. It says, maximum operating pressure 60 PSI. So they were great enough to tag every regulator. And then someone still cranked it up to 90 PSI. So, I could have a plugged filter. I can have too small of an air supply into a regulator that could be causing an issue. You have to look at the point of use pressure regulators. And if you've got a flow controller, a large one that can take the entire system down at 90, don't just stop there. Go to all your pieces of equipment. And if your regulator can be dropped from 90 to even 85 or even lower, then those are the opportunities for energy savings, right? You do the whole plant as low as you can, and point of use, you drop it even further if you can.
So you kind of have to have your arms around the whole thing here to do this properly. So finally, we get to the point of end use. And what I say here is, I always ask the question, is there a better way to do this? Can we avoid using compressed air at all, right? I've seen one case where, Dominic, you were talking about using your compressed air to clean the weld flash off a part. I've seen another situation where you could use a solenoid to vibrate a part clear of the work area where compressed air was being used. And I think that went down to about maybe a kilowatt of power when they were originally using the equivalent of about 50 horsepower of air compressor, which in full load would be about 40 kilowatts. So it can be some pretty dramatic savings by questioning the end use. Do you have any favorite ones here? Do you know?
No, but Dominic mentioned X-Air. They're a good company that specializes in high efficiency nozzles and blow-offs and air knives. I would recommend, if someone does have pieces of pipe for blow-offs or these types, to look at X-Air and see what product lines that may be suitable to replace.
Yeah, and finally we get to that thing called leaks, which is we put after the end use. And it's interesting. I think the greatest challenge I've seen in this one is just the systems to actually get the leak fixed. I was walking through a foundry many years ago, and I'm looking up, and there's all these leak tags all over the place in the plant. And I ended up talking to the maintenance manager, said, "That's great, you got all your leaks tagged." He said, "Yeah, that was great 5 years ago, Steve." 5 years of all those leaks running, that's huge. But the challenge is with the organizations to get the effort to do it and to revisit that as well. Do you have any suggestions around that one, Dino?
We've done a couple of different things, and I agree with you. I've gone into a couple of plants that the leak tags are there still from a year ago and 6 months. And what I found out now is that you kind of work the leak detection with one of the mechanics. And as you find the leaks, you fix the ones right then and there that you can get to, document it. And the ones that you can't, you've got to come back and generate the proper work orders to the maintenance department. But what I'm finding out is that leaks take the they're on the top of the priority list, but then as things go along, other more important items come on the maintenance schedule, such, whatever the case may be, and then leaks just get forgotten.
Yeah, on that document piece, I would even argue that documenting if you could estimate in any way the size of that leak, the magnitude of it, and put a dollar value against it, that may actually, and the fact you've now fixed it, may attract more attention.
Yeah.
Okay.
Yeah, one of the things that we work with energy managers a lot is moving to a program. So it's on this ongoing basis. So you're, over the course of 6 to 12 months, you're scanning, reasonable effort at any given time, but you're doing that scan of the plant, you're finding those leaks, you're repairing them through, the work orders, but it's this ongoing process. Because I think Dominic has mentioned that as well, is, you fix leaks, but then they come back. And so you need to have, it's not a project, it's an ongoing program to minimize that leakage.
Excellent. So I know, Jay, our time's creeping up here, but I think you got a couple of minutes to do at least one or two of these case studies. Are you okay with that? So, and I think the first one's really fascinating. I mean, yeah, this is Dino's case study, where the question was asked, do we really need another, maybe Dino asked the question, do you really need another compressor? Dino, can you describe the situation here, and then you can show us on some graphs what you found?
Right, so the customer's running two 200 horsepower compressors, each with a dedicated desiccant dryer, and they have more than enough storage capacity. Both compressors were in the modulation mode, and they operate obviously year round. So I did some tweaking on the next slide. I had my doubts that they actually needed more compressors, but you can see that at point 1, those are both compressors running simultaneously. I basically just took the compressors and set them to load unload, with the second one coming on as a lag compressor, and you can see that I virtually took one out of the equation, loading unloading. I turned the purge off to both dryers, and the plant was now able to run on one compressor during periods of 3 to 4. So I only needed one compressor to run the plant. Well, the other one unloaded and stayed unloaded until I basically put both dryers back online, and then reconfigured them back to the original setting at 5, and we're back to square one. This demonstrates that whatever you do in the system, such as controls and desiccant purging cycles, all affect how your compressors operate. Ideally, they could move to, the recommendation was, get away from the heatless type dryers, go with something more efficient, such as blower purge that uses no compressed air, and you don't need another compressor. You have 100% redundancy, and the plant can run on one. Now, this was not addressing pressure. It was not addressing air leaks. So obviously there's more opportunities, but just in controls and purge, this is what the compressors were reacting to.
And just a note on this one, that the difference in power consumption of part loads on a modulating compressor versus a load unload compressor is pretty dramatic as well. Because on a modulating, it really doesn't modulate power, it modulates air demand, but it wastes a lot of energy in inefficient operation of the compressor, correct, Dino?
Correct. So the 200 horsepower that was modulating was still pulling a good 120, 130 amps, but I wasn't getting a lot of air on that. But again, it was the fact that we had two compressors set to exactly the same pressure, load, unload. One was modulating, one was fixed, I should say load, unload. And just by adjusting the pressure bands and the way they operated, I was able to load, unload one, and then obviously the purge. Mm-hmm. So those are the things you also have to look at when you're looking at energy reductions. How is the system working with each other with all the ancillary equipment?
Yeah, and I think that's a really important point that we want to drive home here. Is it's not individual equipment. It is how they all interact with each other, and that systems approach really is so important to understand how they are operating together. I think this is a really great example. I think we may move into the Q&As. We've got a bunch to get through on that. Is that all right, Stephen? If the second case study will be in the slides that we send out, so you can take a look at that. But we had a number of questions submitted in advance. We'll get to those. We've seen others in the chat. Some of them relate to ones we have submitted here, so we'll touch on those. But a number of the ones that came in, were focused on how do you generate that compressed air efficiently. So I think we already had some good discussion around, optimization strategies and controllers, all that. If there are any sort of follow-up questions that haven't been addressed in that, we can get to that. We have other questions in terms of, installing the variable frequency drives, and like what compressor types or configuration are the most efficient. Do you want to speak briefly to those?
Can variable frequency drives be installed? Yes, VFD drives can be installed on compressors, but there has to be a little bit of work done to analyze whether the compressor will work efficiently with the existing motoring controls. So it isn't as simple as just throwing on a VFD drive onto a motor control and believing it's going to work properly. There's a lot more thought that needs to be done to it.
And there's probably lubrication issues too, right, Dino, in terms of lubrication at part speed?
Yeah, at part speed, you know, when you take it down to 20, 30% capacity, you want to make sure that we're still getting oil and the motor is rated to run at a slower speed because it will generate quite a bit of heat. And a lot of motors are not designed to do that if they're not on a VFD compressor. So that's the thought behind, you know, a little, it can be done, but a little bit of thought has to go into it.
Mm-hmm. And actually, we had a question in the chat from Courtney about, you know, I believe Courtney works at a mine and they have 6 compressors, all VFDs, sequenced, but, you know, curious about, you know, when setting those compressor pressure settings, they want them to be all equally correct. But is there an argument there on a maintenance perspective? And any comment on that when, you know, you have these complicated systems with multiple VFD compressors on how to kind of manage those appropriately?
I would say that managing multiple VFD becomes a major issue. You know, it's that control gap that you're going to find where they don't fight each other, and which one is going to load first and then unload and then trim with multiple compressors. If they're in the same room or they're satellite compressors, it does become an issue. You're probably almost better off saying, I'm going to use these VFDs flat out, full load as fixed, and then trim with the other VFDs. There isn't a controller out there that could properly manage multiple VFDs, especially 6 of them.
We also had a question from Bazad about the relationship of impact of temperature, humidity on compressed air. And in the chat, we had a number of questions related to inlet and, you know, when is it always appropriate to just be pulling in outdoor air? Is that always beneficial? And, you know, what about extreme cases like, you know, hot, humid summer days, or, you know, when it's -30, -40 outside in the winter? Any tips on that compressed air inlet of managing that or the impact that that has on efficiency?
Steve, did you want to take that one?
Well, I think there's, I mean, one of the things I always think about is when you pull air into a compressor or you pull it from outside of the room, ultimately it has to come from the outside, right? Any compressed air is ultimately going to be drawn from the outside. So yeah, you are going to have the effect of those hot, humid days. There's no doubt that obviously in the winter, cold, dry air coming from the outside is denser and has less moisture associated with it, and therefore it's going to be easier to compress. You're going to get, you know, more air for less power, or the same amount of, more air compression for the same amount of power, or the other way around, reduce the power. So yeah, humidity, again, we don't want to be drawing it from a place where moisture. There's a lot of background noise here. I'm just wondering whether, just trying to see where that's coming from. That's better. Okay. So yeah, so you know, yes, I mean there is a relationship. I mean the more humid the air, the more you've got to treat it to remove the moisture. The hotter the air, the less dense it is, and therefore the harder you have to work to actually compress it and ultimately cool it as well later. Dino, do you have any practical perspectives on that one?
Every installation is different depending on the compressor room, what's in the compressor room, what's outside the compressor room if you're going to pull outside air. And definitely temperature and humidity affect whatever drying system you may have. Higher the humidity, higher the temperature, put excessive load on both refrigerator and desiccant air dryer. So it's one of those things where you look at what you have and then work out, you know, the best design for fresh air supply, hot air exhaust, so on and so forth. But ultimately keep the temperature low, keep the humidity low, and your system will work like a charm.
Mm-hmm. Yeah, and I've seen a situation where they've gone to outside air because it's cooler and drier, but it wasn't cleaner. So they then burdened the filtration, the inlet filters and that became an issue. In fact, in some cases, they removed them. So, yeah, it may be cooler and drier, but it may not be cleaner, and that's as big an issue.
And I've seen some instances where they have a duct or damper bringing in outdoor air, but they may need to temper it or a bit first. Is freezing a concern if you start bringing in like particularly cold air?
Breathing?
Freezing.
Oh, freezing.
Freezing.
No, definitely. So some plants will actually use a portion of the outside air mixed in with proper dampering with inside air, and then temperature controlled. Or during the winter time, they'll exhaust hot air inside. So they close outside. It's all looking at what you have, implementing proper damper control to maintain duct temperature and room temperature.
Mm-hmm. Great. And the last question on the sort of the generating side came from Alan, and was sort of a question about, a lot of these facilities have central plants. Do you have any comments in terms of, what may be better, having that, the big central plant with the storage tanks versus, say, distributed smaller compressors serving end uses?
Sometimes it's just a matter of floor space. Customers sometimes don't have room in a compressor room for storage tanks. Some of them I've seen large tanks located outside the compressor room and then pipe back in. Each one of these serves an advantage. If you can get storage tanks at the compressor room, both a wet and a dry tank, that's great with a flow controller. If you have pieces of equipment that are exhibiting pressure issues when the lines are running, then obviously point of use tanks is a good idea. Some applications call for higher than normal pressure than the plant can do. So I may have a dedicated piece of equipment that does actually need 120, 130 PSI. Don't run the entire plant at that pressure, regulate as low as you can. And yes, some of them have actually put point of use smaller compressors just to feed that piece of equipment. So again, it's one of those things you got to just stand back, analyze the system, look at what you have, and then come up with the best scenario.
And just keep in mind that a smaller compressor may be marginally less efficient too. So there has to be an economy or a benefit elsewhere for going into that. It's, you're going to eliminate leaks, you're going to eliminate piping, the standby on the large plant and so on. And then you pay a little bit for that inefficiency at the point of end use. Mm-hmm. But again, every situation is different.
Right. Are there, characteristics of end uses that, may point to where isolating them on a smaller compressor system or their own compressor might make sense? Like, you mentioned ones that have particularly high pressure demands, but are there other sort of operating characteristics in terms of things that need to be running 24/7 or other aspects like that?
I think that's where it's useful to do an inventory of what your end use requirement is, right? So that would be pressure, cleanliness, right, moisture and so on, right, and then time of use and so on, and use that to really catch that. Do you have, I know you've done that in a number of situations.
Well, there was one particular plant in local to me that was a metal plant that used a laser cutter, but it was at the farthest end of the plant. It was the original 2-inch pipe. The compressors were at at opposite ends. Regardless of what they did, they could not get the flow quick enough to the laser counters to properly cut metal. I said, take that out of the loop and just go with a nice little dedicated 10, 15 horsepower rotary screw with a built-in dryer, tank mounted, and now you're standalone and you don't have to worry about running these big 200s just because your laser's at the end of the loop. So again, it's one of those things that look at what you have, look at what it needs, and determine whether or not what's the best action. And again, yes, there is a call for smaller compressors, and they make sense sometimes, and that's what this customer decided to go with.
Great. And I think and just a note, you said, and a storage with that compressor too, right? Not just
mostly these 15, 20, 25 30 horsepower rotary screws actually now come with a tank mount and a refrigerated dryer. It's like a nice little standalone unit. I don't have to run big compressors. I could just run this small one on a weekend, or You know, if the guy's concerned about the pressure on the lasers or whatever critical equipment with pressure wise, he's got his own little dedicated system. Yeah, there's maintenance involved, but I'd rather be servicing a 20 horsepower screw than the 200 horsepower Copco at the end of the plant just to run the lasers.
Great. We also had a number of questions around leak management. You know, advice on detection or methods for detecting leaks, tracking them, or preventative measures to avoid leaks. There's been a bunch of discussion in the chat around, you know, specific leak detectors. You know, we know there's a wide range in price points, everything from a couple $1,000s up to 25,000 for the like the II-900 that Dominic was mentioning. Any kind of advice on approaching leak management within those systems?
Well, Dominic has the right idea. You purchase a good unit that that provides you with photographs or software that can be utilized. Ensure that it becomes part of a PM. So your maintenance manager is responsible for championing an individual to do this every 3 months, 6 or once a year, and ensuring that they get fixed. As opposed to when major leaks tracked in the field, that becomes part of the PM program. As the work orders are signed off that the leak's been repaired, it gets knocked off. An Excel spreadsheet can be generated as to what's been done, what hasn't been done. Another way of tracking them is a flow meter, as Dominic mentioned. Here's my 860 SCFM on a Saturday. We fixed 50 leaks. The next weekend, it's down to 780. The more you get into it, the more leaks you're going to be able to reduce. And the best preventive measures to avoid leaks, Teflon tape. I know it sounds funny, but the amount of leaks that I've seen on threaded fittings where the maintenance people don't use any sort of pipe dope or any sort, there's my leaks right there. Good quality fittings, quick disconnects, and pipe dope, pipe Teflon tape. Like, that's where my leaks are, mostly at those locations. And the duct tape doesn't work. I've tried.
Not duct tape, right? Okay, we'll remember that one.
Bandages don't work.
Yeah, it's interesting what you said about the flow meter, Dean. I was into a plant that, a while back that you'd been into before, and they were quite proud to show me that on their regular checks 3 times a day, they check the airflow meter and the discharge of the compressor plant, and they know what it's supposed to be, and they keep an eye on it, and they respond when it creeps upwards, right? And they also use the weekend loads to drive things downwards too. So, you know, at the end of the day, we can have all this technology, but I think simple procedures that are executed on a regular basis are really the key to the whole thing. Just like steam traps, same thing, right? And revisit the ones where you know you have recurring leaks. Revisit them, because the leaks are going to revisit them too.
In terms of the different leak detectors, like there's many different price points on that. Do you have any opinion in terms? I know, you know, there's a lot of features. If you go from, say, you know, the $2,000 to $4,000 ones up to those the camera ones that are, you know, over 20,000. There's a lot in terms of, you know, ease of use, usability, but in terms of effectiveness of detecting those leaks, do you have any kind of opinion or recommendations of what people should be looking for?
With regards to the type of leak detector?
Yeah.
Yeah, I'm familiar with a few of them in the field. I know the II-900, and it is up there in price. There are a few ones that are similar that don't have that technology, but all the ones virtually now in the field do come with a camera, do record dB levels, do have a software that you can upload those pictures and leak tags that you've done, and they all give you that information that you need.
Okay, so kind of the key things are, you know, is it giving you the decibel readout? Yeah. And do you have that method to kind of like take a photo, either embedded in the device or using, you know, an app or other system, but to take that photo and track and record those leaks? Yeah.
But the most important thing, and I've done leak training, providing leak detectors to a couple of plants, and the one thing I always tell them, you'll never be an expert in 3 months. You'll never be an expert in 6. I've been doing this for 40, and after a few years, I actually learned how to become better at detecting leaks. And it takes a while to differentiate between steam leaks, air leaks, all these different type of sounds that come through that could generate on a visual II900 or your earphones. So be diligent, learn how to detect the leaks, much more quicker than trying to learn how to use an instrument. It's the leak detection that you're hearing, that you're seeing, that will take a while. And within, 6 months to a year, you become proficient and expert. Now it's much easier.
Okay. If anyone has any follow-up questions to any of these, please put them in the chat there, and we'll look to getting to those as well. There were a number of questions we got on different savings opportunities, and the first few on here, say the first 3 questions, are focused on commercial buildings, which a lot of people don't think of right away when we think of compressed air, but a lot of commercial buildings do have them, say, for control systems. So these questions were kind of focused on what are the main savings opportunities in commercial buildings? Are there better alternatives for those pneumatic automation control systems? And, potentially if they have those pneumatic systems in their buildings, what are the typical costs to switch over to digital controls? And, what is the sort of, cost benefit associated with that?
I'll jump in and say I'm not sure that I would use the savings in compressed air as a motivation to go to DDC, although there are going to be savings, and it would be very difficult to quantify that. I mean, really, you have to look at that from the control system perspective and take the added benefit of that you're no longer using compressed air to achieve that. So on that third question, yeah, and there are certainly advantages to DDC beyond what a pneumatic system can offer. There's just a whole ream of advantages, and anybody who's done an automation changeover will know that. The one thing I will say, though, is that we've often run into commercial buildings where these are older buildings where they have changed over, and it's surprising still to see an air compressor sitting there in a mechanical room and lines connected, and basically there are a lot of leaks in those systems. Sometimes it can be pretty significant where thermostats were removed and lines weren't capped and things like that. So it is worth running around with a leak detector in a commercial building, an older one where you've had pneumatic system in the past, maybe looking at it to see what opportunities are there. Now, Olga, I know you're from a retail environment where you have an automotive shop in the building as well. I mean, in the actual retail environment, you don't have much compressed air, but you probably do have a lot of compressed air in those automotive shops, like the repair shops. So I would definitely look at those systems. Those are typically a smaller system, but they probably don't get looked at significantly. I've seen that in a lot of car dealerships where you've got a couple of reciprocating compressors and tanks in the back room, and nobody really pays attention to it. So it's worth probably doing a basic review of those systems, looking at filtration, again, looking at pressures, looking at, is the receiver waterlogged? I've seen that before now, where the thing's half full of water because the valves are failed. So if those systems haven't seen attention, there's probably some good opportunities there. Dino, I'll flip it over to you.
Yeah, I haven't had too much experience in commercial buildings, to be honest with you, other than a few hospitals. But it's, taking the pneumatic controls off of HVAC and dampers and going with digital controls. So they've done it, and there has been a reduction in horsepower on compressors.
Mm-hmm. And I've heard too, in those instances, just, the real benefits coming from, more accurate control of those HVAC systems, coming out, which you mentioned, Stephen, like that's sort of where a big benefit comes out of it as well.
Or even being able to do sort of, basic control functionality just doesn't exist on pneumatics. But that's really not a compressed air issue. It's more of a building automation issue.
The next 2 questions we have sort of touched on in terms of, what to look for in a broader energy audit that would indicate wanting to look at your compressed air system in more detail on that. And we also talked about, air boosters for those particular end uses, again, your systems. But was there anything else that you may wanted to add to what we've already covered on that for either of those questions?
No, the only one is the, what should I look for in an energy audit? If you want actual hardcore data and readings, and that it usually is involved with a more detailed compressed air audit with power metering, flow metering, and pressure metering at the point of use to get an idea of what pressure drops across the distribution system. So that's what I refer to as a detailed audit.
Mm-hmm.
And on using compressed air boosters, possibly Ryan can elaborate on what kind of boosters. Are we talking about an air compressor booster at a point of use? Or are we talking air booster amplifiers used for a specific piece of equipment that uses air to amplify for hold down clamps or jigs or so on? So I probably want a little bit more information as to what compressed air boosters are being referred to.
All right, Ryan, if you're available and want to pipe in on that, if there's any more information around that, please feel free.
Yeah, hi. Yeah, so, you know, I'm pretty new to this whole sort of thing anyways, but we have some pieces of equipment at our facility that require higher air pressure than sort of the rest of the general equipment. So we were just sort of starting to investigate into this. We're very early stages. But, you know, I didn't even know anything about air boosters. So I was, you know, looking for that. But you guys, you know, went over a bunch of that. So that was very helpful.
Okay.
On the audit piece, maybe I could just add in, you know, it was kind of, I know he's big on this one, but who is doing your compressed air audit too? What you want is objectivity. You don't want someone that's, you know, ready there. I mean, where the report's going to say buy another compressor or buy another piece of specific equipment. I think you want something that's going to give you a very objective perspective on how your system's operating. What's the best strategy for optimizing it, as you said, and not someone that's, you know, has a very specific purpose or outcome in doing the audit for you. And I'm going to say free audits are probably worth that. So, Dino, do you want to add anything there? I know you've got some thoughts.
I do have some thoughts, but you nailed the nail on the head. So yeah, if you're going to use an auditor or someone that's involved in compressed air auditing and energy studies, make sure they're individuals that know more than just outside the four walls of a compressor room.
Mm-hmm.
Jay, I'm going to send along a couple of documents that we've created in the past, sort of an outline for compressed air audit, what you can expect, and then sort of methodology. So maybe you can make that available to folks. You may have seen one of them before, but you probably haven't seen the other one. So
all right,
I'll
we can pass those along. The next question came from Todd. It was looking at piping storage challenges in mining, and I know, you know, the mining situations can be a unique and challenging area to work in this. And Todd, I'm not sure if you want to sort of elaborate a little bit on some of those challenges that you're facing, if you are able to unmute there.
Yeah. Can you hear me?
Yep.
Yeah.
Hey, Todd.
Hi, how are you doing, Steve?
Good.
I've recently got started in this operation. It's an underground mine with, it's a ramp type with literally kilometers of piping. All the compressors are on the surface, and there's very little storage underneath. So I want to look at, you know, helping them figure out the advantages of storage, how much and where. That's really the challenge I'm experiencing.
Yeah, I mean, my experience is, well, I mean, I've done a lot of work in the mining sector, not specifically on compressed air systems, Todd, but my experience actually has been that there's a lot of piping that, because of the way mines grow and shift, you end up with a lot of piping that may be charged, but not actually being used. And so there's a lot of opportunity in simply just charting out what the pipe work looks like, where it's going, what it's serving. Is it actually serving a useful purpose? I mean, that's going to be fundamental ultimately then in sizing, as you said, storage potentially, because part of that will be to sort of inventory those end uses. And in a mine, obviously air is used for more than just doing the work. It's also part of life safety system as well. But I mean, I would actually flip that question over to Bruce. I know Bruce has done a lot of work. Bruce Armitage has done a lot of work in some of his mines on compressed air, but he's got a question here about recommissioning for the compressors. But do you want to add anything to that? Like, I'm going to be careful because that's not an area where I can really claim expertise at all.
And neither can I. I said I haven't done any work in mines for at least 30, 40 years, but suggestions on storage, it would make sense if there's storage at the point of use somewhere within that distribution system. But you're again right, Steve. You'd have to itemize what pipes are actually being used, which ones are not being used, and possibly put whatever you can get down there, whatever size. Maybe a few tanks.
And Bruce, I noticed we do have you on the line, and there's a few other people from mines as well. Does anyone have any comments around Todd's question that maybe you've dealt with in terms of those piping storage challenges underground? If anyone does have an opportunity to unmute there.
Yeah, go ahead.
All right, go ahead. Hi, I'm Courtney from Evolution Mining. We also, we're a gold mine that also has underground mining. One thing I think that we tried, whether we're still using it or not, was having control valves at the headings for each of our airlines that would be closed off when we're not using certain areas or certain sections of the mine to help reduce that.
Yeah, that's actually exactly what I'm referring to when I said is, yeah, because there's a lot of it. I remember one mine, I think they had 35% of their capacity was taken up by sort of leakage in pipes into headings that were no longer used. So yeah, I think and that works, that whole idea of isolating parts of your system works in any context, not just a mine, but it's particularly important in a mine where you have literally miles of pipe.
Mm-hmm. And Bruce, if you are able to unmute there and comment on that, or we've discussed kind of that recommissioning, looking at the end uses, the part with that virtual walkthrough of looking at the sequencing. If there's anything else to add to that, or any further questions on that you may have, Bruce, feel free to chime in with that. Fayez was asking about rebates that may exist for compressor or compressed air system upgrades. And we do know that through Save on Energy there are prescriptive measures within there for compressors or even engineered nozzles or certain components like compressed air systems like that. But Dino or Stephen, are there any other ones that you may be aware of that could be taken advantage of?
Stephen?
No, not really. I mean, I guess the way I look at some of this stuff, a lot of this stuff is pretty quick to pay back, and maybe incentive isn't necessary, but I mean, incentives are always appreciated. So I don't mean to say that. No, I think you pretty much covered it. What I was going to actually, I was interested in, well, a couple things. One is on the mining side of it, just the use of diaphragm pumps, right? Which, if not well maintained, can be huge air users, right? For obviously you need a diaphragm pump to move a slurry or to dewater certain areas. There may be alternatives to that, and to make sure those pumps are actually operating optimally, I think that's worth a check. Mm-hmm. But I was interested in Bruce's question on recommissioning of compressors, like to understand maybe what you meant by that, Bruce. Is this sort of, obviously, is this just the compressor plant? So you've got compressors that are maybe aging, maybe distributed throughout the facility, or in your case, a mine, I'm assuming, how they work together, or is there something more than that? Bruce may not have bandwidth there.
Yeah, he hasn't been unmuting. If he is able to unmute, we can jump back to that whenever it comes up. One other question that I've seen come up in the chat is around heat recovery from the compressors. Like we know, part of that inefficiency of compressed air is a lot of it goes to the heat of compression. We had a question from Alex that they have water-cooled compressors, but what are some of the most, like particularly in the most like cost-effective, or are there low-cost ways that you can start putting that heat to productive use?
Dino? I mean, I would say yes, if you've got air-cooled compressors. It's just sometimes some simple duct work and the proper controls, as opposed to the one that Dino had earlier where the controls weren't simple or weren't being used properly. But Dino?
Well, yeah, I know of a few customers that have water-cooled compressors, and a few that we've actually upgraded from air to water-cooled, and they've used the discharge off the heat exchangers one was in a food plant where they ran the hot water out of the heat exchanger to pre-warm water for some processes and kettles. Another one actually used it for warming up their boiler feed water. So they went from the discharge of the heat exchangers to boiler feed water to another heat exchanger. And that actually reduced the load on their chiller system, on their closed loop system. So there's a lot of opportunities there, depending again on the plant, what process you have where you could utilize hot water, because that temperature is hot coming out of the coolers. And that'll obviously take the load off the, whether it's a glycol or closed loop or open loop or chillers, whatever the case may be, there are opportunities.
If you've got multiple sources of waste heat, like a water cooled compressor could be one of them, it's worth looking at them in a systematic fashion. And there's approaches, integration approaches which will allow you to find the best combination of waste heat recovery options. But yeah, I think what Dino described there are some pretty basic ones that are tried and true.
And Stephen, just a quick question for you, if memory serves me correct. I believe there are incentives through some of the gas companies for heat recovery systems on a compressor. Is that?
I'd have to go back and look at that, but I'm going to guardedly say yes. I think there are, but you always have to be up to date on those things.
Yeah, no, and yeah, you're correct. But yeah, if you can show a heat recovery in certain BTUs off a compressor, the gas companies may rebate a small cost for the ductwork.
Well, there's no doubt that any heat you can take from a compressor and displace natural gas or other forms of fossil fuel is going to have a huge carbon impact too, right? So that's the other piece to keep in mind there, is the carbon impact of heat recovery is going to be very favorable.
Mm-hmm. Moving on, we got a number of questions around system monitoring and some around at the actual monitoring and that, but also a couple of questions just around, what should people be looking for in terms of metrics within their systems? Are there particular metrics or key performance indicators that they should be looking at when they are planning that metering or have that metering in place? And are there particular benchmarks that they can reference or use to kind of judge if the system is operating efficiently?
Steve, did you want to take that one on KWH?
Yeah, I mean, I'm going to come back to the basic metering thing. Anything you can do to look at, I mean, it's one thing. It's one thing to calculate a metric, right? So it could be, these are energy metrics you've got listed here, kilowatt hours per normal. I'm taking that to be normalized cubic meter of air. Kilowatts per CFM is a power metric. So one is instantaneous and one would be sort of averaged over time. They're going to tell you different things, but either one of those, you could be very efficient at generating air, but if that air is not being used usefully, appropriately, or leaked, it doesn't matter how efficient the point of generation is. So I'm going to flip back to that. So that's where just having pure flow, as Dominic talked about to begin with, in addition, so looking at the KPI as well as the actual flow, I think would both be useful. Certainly, you can get an idea of how efficient your plant is overall. If you want to look at, from wire to work, you really have to understand, or any particular end use. When you talk about granularity, if you want to look at any particular end use, you're going to have metering around, around that end use. Time-wise, I mean, the granularity could be, how often can you look at those numbers, right? So I think even a visual LED display for flow, as I mentioned earlier, goes a long way. It's not a hugely expensive item, but with people looking at it, and at the end of the day, you could have some pretty fancy monitoring systems and nobody ever looks at them either because all the data is buried in a computer somewhere. The key thing I've learned in 42 years of doing this is you got to somehow get people in the loop, right? All these things are great. They all have a different purpose. So, looking at energy, KPIs, like you've got on the screen here over time, yes, that kind of looks at the overall energy efficiency of your system. Mm-hmm. Looking at the instantaneous, which would be sort of a kilowatts per 100 cubic or 100 CFM, that kind of looks at what you're operating at now at any point in time, and then looking at the flow at any point in time as well. I think all three of those as long as people are looking at them, and there's a means, or there's a protocol for them to respond. And what's normal, what's not normal, how am I gonna deal with that? So.
Yeah, I think that's a really good point too. Of it's not just the number, but what does that mean in terms of what it should be for your system, for your facility? Yeah. We use some in terms of those benchmarks. There's some that we kind of use as rule of thumb of things to look at or things to aim for, and one of them was in terms of that kilowatt per 100 CFM. Maybe trying to look at getting that under, say, 20 kilowatts per 100 CFM, or if it's above that, there may be good opportunities to improve the efficiency of how you're generating compressed air. For leaks, we like to suggest that people aim for less than 10% leakage rate overall. Pressure drop, I've heard that, from the outlet of the compressor room to the end of your system, trying to get that as little as possible, but down to maybe even just like a couple of PSI, or if it's higher than that, then, there may be opportunities to address pressure drop through the system. Are those sort of like kind of reasonable starting points of where to look, or do you have any other advice on using benchmarks like that?
Well, I think benchmarks are always starting points. And so there's two things, like you can have a benchmark, which is where you are today and where a best practice system would be. Then you can have the ongoing metric, right? So, it's, again, it's all, where do you start, right? And then what are you going to do with that number? How do you respond initially to the difference between where you are and best practice benchmark? And then how do you use that number ongoing to respond to changes in your system as they occur? If everything is flat, then really there's no change, no opportunity. What you're looking for is to be able to drive any of those numbers downwards or upwards, depending on how you look at it.
And for the next two questions from Courtney and Mohammed, in terms of any tools or tips of working with sub-meter data to help maintain that, like you did mention of using that data and understanding what that means and having some reference points on that. But any other tips on that side of it?
In terms of, go ahead.
Sorry, go ahead, Steve.
I was going to say, in terms of sub-meter data, like sub-metering is useful. I mean, I've seen plants that got compressed air meters everywhere, energy meters everywhere, but nobody's using the data. I'm going to come back to the same thing. So like meters don't save energy, okay? People's actions save energy. So where can we put a meter that's going to allow someone to take an action that's going to actually avoid consumption of energy and hence cost? So to me, that's how sub-metering works. And so what you've got to do then is you've got to look at your larger users first. So in terms of sub-metering, you're talking about looking at specific areas of a plant or an operation. You're looking at specific processes and understanding how well it's using its air. Is it worth putting if sub-metering air and to that particular area? Possibly. It really depends on what your opportunity to act is. And that's the same question we ask no matter what type of monitoring system you put in place. But I do think it's worth looking at your overall efficiency of generation, right? So being able to understand maybe flow, total flow in the system, total electricity in, and understanding what that looks like. And then, maybe you want to put, I remember one plant we were into where they did have a couple of sub-meters throughout the plant in different sections. So rather than looking at the total airflow from the plant in absolute terms, that is CFM, they could also see which areas were actually operating, and they would have indicators. So, less is actually better than more in that case. And just keep in mind that meters don't save energy, people's actions do. So I always like to identify the action that this meter can drive, and then I have an opportunity to actually make a difference and make a business case for it too, right? Because at the end of the day, you've got to have a business case for that meter, and you've got to maintain it, right? Meters require maintenance. Any kind of monitoring requires maintenance, and if you don't maintain them, then you can't trust them.
All right. I think, we're just about up on time here. So we will be continuing this. We have, resources. RedScreen is an excellent tool, and it can be used to sort of evaluate potential upgrades or improvements to air compressors and get some of those estimates. And we have other resources that we will be making available. We'll be sending out links or copies of those out after this workshop. In terms of next steps, Helen, if you could put the link to our feedback form, it's just a couple of questions. I would appreciate if everyone could take a minute right now to fill that out. If you have your phone, you can scan the QR code on the screen. It'll take you to the survey questions. We really appreciate your feedback on these workshops. It helps us, deliver better quality products and meet your needs. And the link to that form, Helen has just put it in the chat. So please take a minute right now to go to that link to fill out those questionnaires. As I said, it's a couple short questions. It'll only take a minute to fill out. We will be putting up the information and the recordings, the slides, and some of those resources up on the Energy Manager Learning Platform forum, and using that as a way to kind of continue this conversation as well. So if you have any follow-up questions that you want to post into the forum, the website for that is emss.goldfin.ca. If you don't have a login or you haven't registered for Energy Manager support services, it's free to do so. Please reach out to us on registering that if you haven't already. And a reminder that next Tuesday, the 13th, I believe that's Tuesday, we will be having our typical drop-in office hours. So it's from 1 to 3:30 p.m. Drop in when it's convenient, stay for as long as you want. The main topic will be discussing compressed air systems if you have any questions, but if there's other things you want to discuss, we can have breakout rooms for that. So it's informal discussions, but please feel free to drop by and join us for our coaches. Thank you everyone for joining us today, for your time. Thank you Dino and Stephen for your expertise and sharing your knowledge, and to Dominic as well for sharing your experiences at Prestran. Really appreciate all your support in this, and I think it's been really useful and valuable information that we've sent out to the participants and the energy managers. So again, please fill out that feedback form. We really appreciate any feedback that you can give us. And that's the end of this. We will be sticking around for a few minutes if anyone does have any questions that they want to kind of unmute and pipe in. We'll be sticking around for a couple of minutes at this point. But otherwise, have a great day, and we'll see you again at the next one.